Okay, very good morning, dear students. Welcome for physics class. Today we are going to study one more chapter, new chapter. It is chapter number 7, alternating current. Alternating current. Okay. As per the previous year of examination blueprint, there will be 7 marks questions have been asked from this chapter, and those 7 marks includes a numerical problem. So that means from this chapter we are going to get one numerical problem for your annual examination, right? Okay. So this is a chapter which explains about the current, that is alternating current, that we are going to use in our home. Okay. So basically I want to clear you that there will be two types of current. One is direct current. And in the chapter number 3, that is current electricity, whatever the topics we are going to study, those are all related to the direct current. And one more is alternating current. Okay. So before going into the deep of this chapter, I want to say something basic for your knowledge. Okay. Right. Chapter direct start ಮಾಡೋದಕ್ಕಿಂತ ಮುಂಚೆ ಏನು ಮಾಡ್ತೀನಿ, ಸ್ವಲ್ಪ ಬೇಸಿಕ್ಸ್ ಅನ್ನ ಹೇಳ್ತೀನಿ. ಅದು ಎಸೆನ್ಷಿಯಲ್ ನಾಲೆಜ್ ನಿಮ್ಗೆ ಇರಬೇಕಾಗಿತ್ತು. ಓಕೆ ರೈಟ್. ನಮ್ಗೆ ಗೊತ್ತಿರೋ ಹಾಗೆ there will be two kinds of current. One is direct current and another one is alternating current. So direct current, usually current ಅಂತಂದ್ರೆ whenever a charge crosses a cross sectional area, then there will be a generation of energy that is called as electric energy. So in one more way you can say it like the rate of change of charge is called as current. So when can we get the current? When the charge is moving from one place to another place. From that process, whatever energy we are going to get, that is called as electric current. Okay, right. Direct current, it is the unidirectional current. It is the unidirectional current. Just look here. So here we are having an electron. It is an electron. It will be moving in this direction. It will be moving in this direction. Then we are going to get current in the opposite direction. Here the electron will move along the same direction, because whatever voltage means whatever work we have done on the electron, that will be along one direction. So therefore electron will be moving along one direction. So whatever current we are going to get, that will be in the opposite direction. So throughout the process we are going to get the current in this direction, that is unidirectional current, and this is called as direct current. Okay. In order to get the direct current, we need to apply the direct voltage, DC voltage. Okay. But in the case of alternating current, look here, the electron is not going to move along the same direction. Instead of that, the electron is going to oscillate simple harmonically. The electron is going to oscillate simple harmonically. Just look here. In the case of DC, the electron will be moving in one particular direction. So because of that, we are going to get unidirectional current. That means one directional current throughout the process. Okay. But as we move, in case of the alternating current, you look here, if it is an electron here, if you have applied alternating voltage, means the work done will be half in one direction and half of the work done will be in the opposite direction. So what happens? The electron is going to move first in this direction. Okay? The electron is going to move in this direction. When the electron is moving in this direction, whatever current we are going to motion along this direction, but instead of that, it will come back to its original position. It will come back to its original position, electron. So whenever the electron will be moving in this direction, the current will be generated in this direction. Okay? Look here, this is called as AC current. Instead of moving in one direction, the electron is going to oscillate simple harmonically. So that's why we are going to get two directional current here. Okay? Look here, whenever the electron is moving in this direction, the current will be generated in this direction. But whenever the electron moves in the opposite direction, the current also reverses. Okay? Right? This is what we can call it as alternating current. Is it clear? Okay. Next. Also this alternating current, we can say it as a sinusoidal current. Because whatever current we are going to get here, if we want to represent that with the help of graph, we need to use the sinusoidal graph. Okay? You just listen here. So whatever current now we have got here, one is in this direction and next time opposite direction. If you want to plot it on the graph, just look here. Okay? So whatever horizontal axis I am having, I consider it as a time axis. Horizontal axis is time axis. So whatever vertical we are having here, that is current axis. I means current. Okay? So, whenever the electron is moving in this direction, the current is gradually rises. The current is gradually rises. Look here, the current is coming in this direction. Suddenly it will not acquire any high value. It will gradually rise to a particular value. Look here. Okay, now the current has been raised or developed in a particular direction up to the peak value. Peak value means the maximum value. We can say it as an amplitude. Okay? But whenever electron has been reached the extreme position, there, what happens? A fraction of a second, it will be at rest. So at that time, the current gradually decreases to zero. Okay? Current gradually decreases to zero. Because whenever the electron is moving, whenever the charge is moving, at that time only we are going to get the current. So here, during this motion, the electron or the charge will start from this point. So that's why the gradually current will increase. But whenever the electron reaches this point, it will be at rest for a fraction of a second. The very minute time it will be at rest. So then the current will decrease to zero because the charge has been stopped. Whenever the charge stops, we are not going to get any current. Okay. Next, when the electron or the charge starts motion in an opposite direction, whenever it starts in this direction, the current direction also takes in the opposite manner. Okay? Then what happens? The current will be okay? Whenever the current has come in the opposite direction, here also the current increases gradually. Gradually the current will be increases. And then when the electron reaches its original position, again it will stay at rest for a fraction of a second. At that time, the maximum current will reduce to zero. Right? So look here, the vertical axis represents current and the horizontal axis represents time. So here, current will gradually increase and comes to zero. In next, current will increase in the opposite direction up to here, this point, and again it will become zero. Is it clear? cycle. Okay. So here you can say that for every half cycle, we use this much. It's the half cycle. And this is second half cycle. For every half cycle, the current is changing its polarity. The current is changing its polarity. Polarity means its direction. For every half cycle, its direction will be reversal. Okay. Next, this process will continue. Okay, next, the current will be generated in this manner. Is it clear? So this is about AC or alternating current. Okay. If you want to get alternating current, you must apply the alternating voltage. Alternating voltage. Is it clear? Okay. So here, the number of cycles per second is called as frequency. Okay, here, the number of cycles per second is called as frequency of AC. Frequency of AC means in 1 second, how many such cycles are performed? How many? This is one complete cycle. Okay, one plus and one top. This one plus and one top is one complete cycle. In 1 second, how many cycles are being completed? That is indicate the frequency of alternating current. I think all of you know that. In India, what is the frequency of alternating current? 50 Hz. In India, 50 Hz is the frequency of alternating current. That means in 1 second, in India, in 1 second, whatever current we are using in our home, in office, okay, that is in 1 second, 50 such cycles will come. 50 such cycles will generate. Okay, that is about 50 Hz that we are going to use in our home day-to-day life. Okay, right. And here, look, the AC voltage, alternating voltage source will be indicated with this symbol. Will be indicated this symbol. In the laboratory, you can observe. You can find there ammeter, voltmeter. Ammeter means it is a device used to measure the current. Ammeter. Voltmeter means it is a device used to measure voltage. If you are going to measure or deal with any alternating current, then you have to choose a device on which this notation has been indicated. This notation has been indicated. Okay. This is indication of alternating source. And one more, in some of the ammeter and voltmeter, you just going to find the straight line. The straight line means it will be used for DC current or DC voltage. If you want to deal with any direct current or direct voltage, DC voltage, you have to take the device or apparatus, that may be ammeter or voltmeter, which would have this indication. Okay? Right. So this is a basics about alternating current. Okay, and one more thing. In India, whatever voltage, alternating voltage, they produce our home, that will be of 220 volt. 220 volt. Okay. Okay, now we'll move towards the definitions, exact definitions of alternating voltage and alternating current. Just whatever explanation I have given, that is about how the current has been generated, in which manner we are going to find the alternating current. Now, we move towards the definition. The first, alternating voltage. Alternating voltage is the one whose magnitude varies continuously. Alternating voltage is one whose magnitude varies continuously and the direction reverses periodically. periodically. That means for every half cycle, the direction will be reversed. The polarity will be changes. Okay? So this one, whose magnitude changes continuously or else with time. Its magnitude changes continuously or else with time. The magnitude changes with time and direction reverses periodically. If you want to show the practically, so look here, as I draw on the same diagram. So x-axis is going to represent time and y-axis represents the voltage. So you can consider here the voltage both are same. The only difference is when we are not drawing current out of the circuit, that is called as EMF. If you draw current out of the circuit, that is called as voltage. Okay. So I will consider E of V. Anything. E of V. So just I will consider V here. V in the vertical direction. So for first half cycle, voltage is going to travel in one direction and again it will reach up to 0 and next it will in the opposite direction, again it will reach to 0 and the next again in the earlier direction and reaches to 0, right? And again here in the opposite direction. Okay? Yes. Okay. Now, the time taken to complete one complete cycle. The time taken to complete one cycle. That means from here to here. From here to here. Whatever time is taken, that will be called as time, capital T. Right? And for half cycle, the time will be after, that is T by 2. For this much, that is quarter time, that is T by 4. And for here, 3T by 4. 3T by 4. And here, 1 complete second, that is T. Is it clear? Okay. If you consider it in terms of angle, one complete cycle means 360 degrees. One cycle complete means 360 degrees. In terms of angle, I am writing of this data. Let us careful. It is 360 degrees. Then what about half cycle? That is 180 degrees. Then quarter cycle 90 degrees. And from here 270 degrees. Please use the earphone for the clear audibility. Okay? So for quarter cycle, if you want it in terms of an angle, you can call it as a phase angle also. So for quarter cycle 90 degrees, because for one complete cycle, the angle will be 360 degrees. So for half cycle, the angle will be 180 degrees. And for quarter cycle, the angle will be 90 degrees. And for this much, the angle will be 270 degrees. Is it clear? And here the magnitude of the alternating voltage is changing continuously. Then, if you want to write the alternating voltage at any time, at any given time, t, small letter t, then the equation will be the alternating voltage T, look here, the small t, any given time, capital T means for time taken for one complete cycle, for any time t is given by, look here, V is equal to V naught sin omega into t. Instead of t, you can take t also. Okay, some of the textbook can consider D, some of the textbook can consider D as the alternative voltage. Here V means, look here, V means that is alternative voltage at any time, given time T. Okay, here V naught is the peak value of alternating voltage, peak value of alternating voltage, or else the maximum value of alternating voltage, or else amplitude of alternating voltage. Amplitude of alternating voltage, V naught. In this graph. So look here, it is the maximum value, right? So you can write here, this is the V naught. Okay? This is also the maximum value amplitude, V naught. Here this one. This is also V naught, but that is in the opposite direction, so we will write it as a minus V naught. Minus V naught, right? So V naught means the amplitude of alternating voltage. Omega means it is the angular frequency of alternating voltage. Omega is alternating voltage, angular frequency. And T is, it is the time at which we are finding the alternating voltage. Is it clear? Okay, and here also omega is, you can write here, omega can be written as 2 pi divided by T. 2 pi. 1 by 6 is, that is here, 2 pi here. Okay, omega is 2 pi here for us, 2 pi by t. Next comes to be alternating current. Alternating current. Okay, alternating current means same definition will apply here. It is one whose magnitude varies with time and direction reverses periodically. Direction reverses periodically. It is one whose magnitude changes with time and direction reverses periodically. Direction reverses periodically. The same diagram we can draw here. Instead of V, just we have to take I here. Instead of V naught, we just have to take I naught. So graphical representation will be like this. So I look here. Okay? So the horizontal axis is going to represent the time, vertical is going to represent the current. So for the other half cycle, the current is also changing its direction, changing its polarity. And the maximum value of current here, this is what we can call it as the peak value of current, the maximum value of current or amplitude of alternating current. And that we are going to represent as a I naught. And here, in the negative direction, the current has reached the maximum value. So we can call it as and angle also same as this. Okay. Next, the alternating current at any instant of time t. Alternating current at any instant of time t is, look here, instead of V, I'm going to write here I is equal to I naught sin omega into t. So again, I is an instantaneous alternating current. Alternating current at an instant time t. And I naught is the peak value of alternating current, or else you can say it as amplitude of alternating current. And as usual, omega means the angular frequency. Here t means it is time, instant of time. T means instant of time at which we are finding an alternating current. Is it clear? Okay. So these are the definition of alternating voltage and alternating current. So next one is mean value or average value of alternating current over a half cycle. Please be careful. It is average alternating current over a half cycle, not a complete cycle. If you go through the mathematics, go by the mathematics, over one cycle the average value will be 0. Because at each half cycle, the current or voltage, alternating current or alternating voltage, for each half cycle, they are going to change their direction. They are going to make opposite direction for each half cycle. And magnitude will be same. For each half cycle, the magnitude of alternating current or alternating voltage is same, but the direction is opposite. So if you go by the mathematics, the average value of alternating current over one complete cycle is 0. So that's why we are going to consider average value of alternating current over a half cycle. Okay. So here the average value of alternating current over a half cycle is equal to 0.637 times of the maximum value or peak value of alternating current. Peak value of alternating current. That is, look here, average value of alternating current over a half cycle, is 0.637 times of peak value of alternating current. Okay. If you write this by using the equation, average value of the mean value, we can write average I subscript m, right? And 0.637 times of peak value of alternating current. It's what factor or with what alphabet we are going to represent. That is I naught. As we have written in the earlier case here, right? I is equal to I naught sin omega t, we have to know. So there I naught is the first peak value, is the amplitude. Is it clear? Similarly, average value peak value of alternating voltage. Average value of alternating voltage, average value of alternating voltage over a half cycle is 0.637 times of peak value of alternating voltage. Alternating voltage. Right? Okay. So, if we want to write it in an equation form, then put here average value of alternating voltage. We can consider V mean. So V can also make E also. E also you can consider. What else? V. V means equal to 0.637 V naught. V naught. Okay. Okay, next concept is RMS value of alternating current. RMS value of alternating current. RMS value of alternating current, and we can represent it as a IRMS. Okay, is it visible? Right, IRMS. Okay. What we mean by the RMS value of alternating current, that is IRMS. The RMS value of alternating current is nothing but that direct current means the RMS value of alternating current is equal to the direct current which is when flowing through any resistor, which is the direct current which is when flowing through any resistor for a given time produces heat as that produced by the alternating current, when it is flowing through the same resistor for a same interval of time. It's clear. So just consider a direct current, and we want to make it flow through any resistor for any given particular time. Whenever direct current is flowing through any resistor for a particular time, it will produce some amount of heat. Okay. So now, if we would have used alternating current for the same resistor for the same time, whatever heat we are capable to generate, the same amount of heat we have got from the direct current when it is flowing through the resistor, and that value of direct current is called as RMS value of alternating current. Are you getting my point? Alternating current is nothing but RMS value of alternating current is nothing but it is equal to the direct current which is flowing through the resistor for a given interval of time will produce the heat as that of an alternating current which is flowing through the resistor, same resistor Okay, the DC current which has been produced the same heat as that of alternating current is called as RMS value of alternating current. The long form of RMS is root mean square value. Root mean square value. Okay. RMS value of alternating current means that direct current which when flowing through a resistor flowing through a resistor for a given time produce the heat as that produced by an alternating current when flows through say resistor for a say time. It's clear. Listen it carefully. Whatever points I am going to write on the board, you just have to copy those points. Students. Okay? However, I am going to send you the printed notes back. But when you write the notes by your own hand, that will be more essential. That will cause more effect. That will be affected. Okay? And listen here. You have to maintain the two notes. One is class notes. That is whatever I am going to write on board, you have to copy that in your class notes. And one more is your home notes. That in that home notes you have to write whatever printed notes are assigned to you. You have to copy that to your home notes. Okay? Right. This is the meaning of RMS value of alternating current. Okay? If you want to write it equationally, then RMS value of current, alternating current, IRMS, is 0.707 times that of the peak value of alternating current. So that is 0.707 times of peak value I0. Okay? So similarly, RMS value of alternating voltage. RMS value of alternating voltage will be written as VRMS is equal to 0.707 times of V0. V0 is peak value of alternating voltage. Peak value of alternating voltage. Is it clear? Okay, next one is phasor diagram. Phasor diagram or an arcane diagram. Phasor diagram or an arcane diagram. Phasor diagram. Or we can also call it as This represents arcane diagram or phasor diagram represents alternating voltage and alternating current as a rotating vector in an anti-clockwise direction along with the phase angle in anti-clockwise direction. Okay, so phasor diagrams means they represents alternating voltage and alternating current in terms of the rotating vector. In terms of the rotating vector that is in the anti-clockwise direction along with the phase angle in the anti-clockwise direction. We'll come to know more about these in the next class where we are using these phasor diagrams to derive some relation between current and voltage. That is nothing but they are going to represent whether the current is leading the voltage or voltage is leading the current, or whether there is no phase difference. Simply, we want to say it in very simple manner means just they are going to represent the phase difference, phase angle between alternating voltage and alternating current. Is it clear? Let's write the definition of phasor diagram. So again and again I am saying that you just have to note down whatever I am going to write on the board. Okay. Phasor diagram. It is a diagram. It is a diagram which represents alternating voltage and alternating current as a rotating vector in anti-clockwise direction along with the phase angle in anti-clockwise direction. Along with anti-clockwise direction. This is called as phasor diagram. For example, I've drawn a phasor diagram just to show you how it integrates the phase difference between alternating voltage and alternating current. So look here, along horizontal axis, I have taken it as a time axis, and upwards vertical axis, I consider it as a alternating voltage, and downward vertical axis, I consider it as a alternating current. Okay, right. So here I just represent an alternating voltage represent V naught by G naught. And similarly, we consider alternating current also in this quadrant. This is I naught. And here, the angle is omega t, then this will be pi by 2 minus omega t. So here, one line is going to represent alternating voltage, and one line is going to represent alternating current. So angle between them is going to represent the phase difference between alternating voltage and current. Okay, just try to understand the definition. This thing will make it clear from the upcoming derivations. Okay, it will be clear from upcoming derivations. Right? So to understand this one, you must have to see the next video lecture. Okay.